we get to see the presentation that I've been waiting for a while. Tom has done a tremendous amount with this station that's so far away and yet so close. Some of the things he tells me are very interesting, including remote capabilities. So without much more, Tom, please, let's get you set up and tell us a lot about what you've been doing.
Oh, okay, that's just the cover. I was just saying, where all the like template go and all that stuff. All right, so while he's setting that up, Jack came to me and at the last meeting and asked if to do some talk on the station in Barbados. I'm wearing my Barbados colors today, and so interestingly enough, just looking back on it, it's actually 20 years in February. So the first time I went there, and really kind of took the station over in earnest in 2001. So it's been a lot of years. You'll see it in the pictures. It's like the station never looks the same in two pictures in a row, and that's kind of the way it is. So, I think for the presentation today, we could talk about operating, we could talk about, antenna design. I mean, there's an endless number of things, as Jack just indicated, to talk about. But I think one of the things that's somewhat unique that kind of, I think, stimulated the question is there's a lot of automation that's gone into the station. It's kind of a personal thing with me. And I just want to talk about thinking about a single op station. And there was a time at which I was going to call this the no knobs contest station. And that is basically how to operate a contest station with no knobs. And I haven't quite achieved that, but you'll see kind of what I did. And just things that basically drive operator efficiency. And I will talk about operating a little bit because you can't stop. And we're all like talking about antennas, so we'll talk a little bit about antennas along the way. But most of it's really about how do you design a station. And admittedly, these are all my personal preferences. Lots of people could look at this differently. But how do you design a station that is as easy to operate and as automated as much as possible? So basically, all you're focusing on doing is strategy and working stations, and everything else is taken care of for you. Okay, we good? Okay. Do I have a clicker, or you have a clicker? How does that going to work? All right. So anyway, so this is kind of the first slide. So this is oops. Let's go back. I see you're pressing the buttons. All right. So kind of the history of the station. This is 1994. This is before anything's been done. There was a set of guys, K4FJ, K3ZR, K3ZJ, K3KG, and I think somebody else. They used to go to Barbados, and they used to set up these field day style operations and for CQ Worldwide. And in the course of doing that, they ran into a gentleman, AP6PW, who I believe that is in that picture. And AP6PW is basically a manager of plantations. He's basically like a farm manager. And he was getting a new job to basically manage a plantation in this town called Worley. And he had been connected to these guys, and he said, I think I might be able to enable you guys to put up more permanent towers and build a station at Worley Plantation. And so he was going to live on site, and he actually had this building, which is what's behind him, and that's actually the location of the station, is that building there. And that's where ultimately they would set up all this equipment and actually build a station. Actually, he put in 3 towers, and he actually did a lot of that work himself. Certainly the cement work and everything else that went with it. So that's kind of what it looked like. So in 1994, there was nothing at that location. Just for kind of a little comparison, remember that, look at that red roof in the back. So this is kind of a, let's see, which way do I go? This is kind of a more recent picture, kind of an aerial view, just kind of a sense of what it is. Remember that red roof in the back? Well, that fell down about 10 years ago. And that's just kind of the nature of this, it's kind of the nature of the world down there. But you see, it's kind of in the middle of a plantation, kind of in the middle of nowhere. And I like to tell people, you've all seen pictures of PJ2T where they're out on the veranda and they're sipping tea, like looking out at the ocean. Well, this isn't anything like that. It's completely different. So it's a little bit out in the open. The plantation manager actually lived in this building over here, which is actually quite cool. It's basically a sugar mill. That's what that round thing is. They actually, ground sugar, and they built a house around it. And he lived in that house, and he basically managed his plantation, which is about a half a square mile. And he also took meticulous care of the grounds. Like the grass was like this soft, squishy, like very, very soft, almost like a tumbleweed type of a grass. You could walk on it in your bare feet and stuff like that. But eventually they moved on. They combined a bunch of farms, and just the economics of farming are really bad. And eventually a new guy moved in here who didn't really take over the grounds at all. And then he was probably in that location for probably 8 or 9 years, and then he moved out, and it's been abandoned since then. And by abandoned, I mean literally abandoned. Like the windows are open, there's like animals inside, there's like birds flying in, the whole building's full of feathers and bird crap. It's really, really awful. But the net of it is, we went from this beautiful, meticulous gardens and vegetables and flowers and hedges, to now it's not really that well maintained at all. So that's kind of the nature of it. So it's a little depressing. It's unoccupied, so there's like nobody there maintaining it, nobody lives there. So you kind of drive up and you don't know what's going to expect. There's a time when the grass was over the roof of the car. We were like driving through the grass, hoping we didn't like run into a tractor or a plow or something. So that's kind of the nature of it. I'll talk a little bit more about the antennas later. I just want to give kind of a sense of the lay of the land. And then this was the famous iconic picture. If when the guys built the station, the AP9Z, if you remember that call, that was a call that these guys used as a multi-single. AP9Z was the call that John Laney used to use in CQ Worldwide CW back in the time. And they had this picture on their website. So, ooh, how glamorous is that, right? And in 1998, they had like a last minute cancellation. I actually got to operate, and so I basically jumped at that and actually operated ARLCW from this location in 1998. And I was lucky enough to win. First international win. It was a big deal for me, but that was the first time I was there. But I really wanted to do CQ Worldwide. So CQ Worldwide wasn't available that year. It was available the following year, 1999. And so that was going to be my chance to do CQ Worldwide. I set a goal for myself of I wanted to break the North American record. So I went to the station, got all set up. The station was kind of a little bit rickety. It's kind of very difficult to keep things working down there. But I eventually got it all worked up. I get 1999, I get going. And with about 4 hours left in the contest, it all kind of fell apart for me. Basically, the fatigue, the dehydration, just the pure concentration. And I struggled pretty much all day Sunday. The delusion started to take over. Anybody who's done 48-hour contests know what that is. It's a very hard thing to explain. But with 4 hours left, I just could not concentrate anymore. I just could not translate voice into keystrokes, and basically collapsed in the end. And that was 1999. 2000, go back again. Before I go, I get a call, says, oh, by the way, the 40-meter beam doesn't work, and a bunch of the tips on the 10-meter beam have rattled off, and if you can look for the aluminum, go find it. And oh, by the way, the station's been so hard to maintain, yours is probably going to be the last operation from this location. And we're going to tear it all down. So it's like, all right. So basically get enough of a station going along. I'm closing in on the record. Not long after I convinced myself that I was going to break this record, the same thing happened. It kind of melted down at the end. It was probably the low point of my contest life. It was awful. It was awful. Like 2 huge, massive defeats. And CT1BOH actually wrote me a very, very nice letter. I'll respect him forever for this letter of encouragement that he sent. That kind of kept me going. But there's a bunch of lessons in all of that for me. And the other one is this station's got to get easier to operate. And it's got to get easier to set up. And so the other thing was, the contest is over. I'm looking around at all these towers. I said, I'm working for a living. There's no way on earth I'm ever going to be able to build this station myself. And so my wife and I decided, why don't we see if we can take it over from them? So the land is rented, but the equipment was owned by the people who put it all up. So would the landlord extend the rent to me? And likewise, could I buy the equipment? And K4FJ basically said, he says, basically, you have no idea what you're getting yourself into. He says, just walk away. And the sentence, the letter ended, I tell you this as a friend. That was his advice. And I told him, well, all right, you didn't quite convince me, but you got my attention. I said, I'm not looking to rent it out. And he said, well, okay. He says, renting it out was half the problem. You have people, stuff missing, stuff breaking, people complain, people are expecting this is going to be a resort, all that other type of stuff. He says, if you're not going to rent it, that's going to make life a lot easier. So my wife and I decided we're going to take it over. So we actually did a summer trip down, and N5KO, K6AW, K5ZD, and we actually tried to get as much of the station working together. That was an experience in and of itself, working in the hot sun. And we eventually got the station running, and then this is a picture of CQ Worldwide 2001. So this is the station, I own it now. It's sort of working. And while it looks like SO2R, it really isn't. And the Daiwa switch kind of just to the upper right of my head there, that was basically the radio and amp on the left and the radio and the amp on the right. So basically band changing was switching the thing, turning the amplifiers, putting the radio into, putting the amplifier into standby mode, so I didn't tune into the wrong antenna, selecting the antenna, turn the radio, make sure I had the right antenna. The radio has to be an FSK in order to tune because it's a TS850, and then go back. So that was what a band change looked like. It was basically turning the knob, switching the antenna, switching this big switch in the middle, testing, make sure I had the right antenna, then tuning up and then going. So the kind of the good news in this story is the kind of two sets of good news. One of them is I finally achieved my goal, and I'm setting a North American record. And as it turns out, it actually won the contest outright. So it was the first time I'd ever won CQ Worldwide. So, but I remember when the contest was over, I got out of that chair and I slumped down on a couch back when we had a couch there. And I told my wife, this is the hardest thing I've ever done. And that was a lesson, is that this station's got to get easier to set up and it's got to get easier to operate. And that kind of set me down the path. Plus, if I was going to compete, I really had to do SO2R. Just because there were two radios doesn't mean it was SO2R. It was basically two parallel stations that couldn't be operated at the same time. Remember, this is 2001. We'll get to that. So just a side note on computers. Computers are the one thing that I could not keep working down there. Like a desktop computer, every time I went there, the whole computer had to be completely disassembled, all the contacts cleaned, and all put back together again. That was the hardest thing. I mean, I don't have PJ2T, where basically the corrosion basically dissolves the circuit boards. It isn't quite that bad, but it's one step away from it. So I built myself an 8x2 box so I can automate some of the switching. I got my Dunestar bandpass filters. And then I kind of built a control box. This is kind of the first version of it. And basically it allowed me to select the antennas. It basically took the bandpass information on the LPT from the computer, so it knew what band I was on, knew what antenna choices I had, so I could switch the antennas from this. I didn't have any band switches, so I was able to keep the coax cables off the operating position, because that kind of keeps moving all the boxes around and all that stuff. Did the headphone switching for SO2R. So it basically did a lot of stuff and made the station a lot easier. And ultimately, it looked like this. And so you see I painted the walls too. So now it was true SO2R, and it was symmetric, which means it wasn't like the left radio can only do certain bands and the right radio can only do certain bands. They can both do all the bands. The coax connectors are off the table. Because you got the coax and the coax is stiff and the watt meter doesn't want to stay where you want to put it. If you notice up in the right-hand corner, that's a box of laundry detergent on the top of the box. That was to keep the top of the Centurion amplifier from vibrating. I mean, the amplifier worked great, but the mechanical design of that looked like it was done by the kid in the mailroom. I mean, it's really horrible. So that's what the station looked like. A lot simpler, pure SO2R. But this is one of the drawbacks of that. That's a Daiwa watt meter. No, that was the watt meter. So this is what was inside that control box. So I don't know if any of you have ever seen wire wrap before. In fact, I still have that board. In fact, the only purpose of keeping that board all these years is so I can take a picture of it. But if you notice, the wire wrap is white, it's red, it's blue, it's yellow. So what that means is, as I started to think about new antennas, it was damn near impossible to change this thing. And it was hard. And eventually it became too complicated. So I was kind of like, well, I can't automate the station I can't change the antennas anymore because then I can't automate it. And I was kind of in a bit of a deadlock. And so it's like, okay, I got to do something different, but I didn't know what. And then I kind of ran into another problem. And that is they kicked me out of the house. So they came to me with a, Dear Thomas email. The guy I rented from is a lawyer, so he's very formal. So sorry about that, Andy. But, Dear Thomas, so they basically said we need the building back. One of the other co-owner's wife wants to run a store, sell like terracotta pots and hammocks and plants and stuff. So it's like, what do I do? So it turns out that there's a room in the back, a very small room. It's about 8 feet by 9 feet. And most of it's a built-in closet and there's a sink. But it's got a separate entrance, so it's not connected to the rest of the house. So it's like, we kind of said, okay, we're going to do that. But it meant that I did not have much room anymore. And so we're in this room, and this room was basically, I'd just been sitting there. I had, animal carcasses and all sorts of stuff. It was kind of hellacious to take out. That back wall was made out of limestone. So the water seeps through the limestone. So if you have aluminum against it, it dissolves it, turns it into paste. So that 8x2 box basically wore a hole about this big in the back, turned it into basically this white paste. But the net effect of it is I had this really small area now. And I couldn't keep the rotor boxes had to be off on the side. They were kind of a little bit out of the way. So you couldn't like operate and look at the rotor boxes at the same time. So it's like, okay, I'm working, guys. I want to change the antenna. I'm turning the rotor box. I'm still working, guys. It's like, oh shit, I'm turning the rotor. I'm way too far. Now I got to come back the other way. So it was kind of a few things were coming together. I was out of space, and I really needed to do more automation, and I need to get this operation to be a whole lot more efficient. So kind of coincident with that, I was at this Livermore flea market, not far from here, when they used to have it there. And there was this guy selling a CD, a Visual Basic 5 for $1. And I bought that. And so it's like, okay, if I can do some type of user interface and I can get some type of processor, and I've been doing I've been looking at W8ZR, did a bunch of articles, including we did one on an automatic antenna tuner using a basic stamp processor, but those were like 60 bucks. So I wanted to automate the rotor controllers as the first project, but I didn't want to spend 60 bucks on a processor for each one of them, especially since I didn't really know it was going to work. So I was trying to figure out what to do, but I just make my own interface board and then use one of these commercial software products, these rotor interfaces. But I had 4 rotor boxes. I didn't want to have 4 windows. So that's kind of what started me on this journey. And just kind of talk a little bit about what I was ultimately trying to accomplish. So this is kind of the antenna farm today. And I'll kind of get into what I turned this all into after that long preamble. So 3 towers. The tower on the left is 90 feet of Roan 25. On the very, very top is a 5-element 10-meter beam. Below that is a 2-element 40-meter Moxon. My favorite antenna. Dave Leeson's not here. When he calls me on 40, he always says, gee, you're really loud. You must have a great antenna designer. And then kind of on a side mount is a Skyhawk. And it's not that far offset from the tower because the Roan 25 is kind of small and I didn't want to build big cantilever, but it can swing between US and Europe, which is about 90% of the stations that are ultimately going to work. Kind of on the crank-up tower, there's a 5-element 15, a 4-element 20, and then on the tower on the back is another Moxon. I won't explain why I have 2, but there's another one. And on top of that is a C4 that's turned 90 degrees. That's probably my south antenna. That's like when the LU calls in, you want to be able to work them really easily. So that's kind of the antenna farm that I wanted to operate. It's a lot different than when I started, and there's no way I could have done that without programming. And I read that PJ2T article in NCJ, and K6AM built that brilliant switching matrix on the wall. And I looked at that and I said, wow, that is brilliant. I actually stepped through how it worked. It's like, man, he really did a phenomenal job. And that's all well and good until something changes. That thing needed to be programmed. That was not the right way to do it. First of all, you could do it for 20 less IQ points. And so he did this brilliant job. But the problem is, what is it going to look like 5 years from now? So the other thing that I needed to integrate in, I don't have a picture of this, or you could argue I've got the best picture of it, is my receive antenna array. So out to the north is a field. And so I've got an array of 4 short verticals, like 15 feet. And so they're in kind of a traditional 4-square configuration. And N6RKO is not here. It was actually very helpful for me. He basically said, don't worry about matching it. Just put a transformer at the base. You don't need active amplifiers. You don't need any of that stuff. So anyway, what this picture is basically a bunch of AM radio stations on the left, and then basically change 90 degrees on what it looks like. So no guarantee is that any of those stations are actually in the null. The sad thing is post this array of hurricanes, all those stations are gone now. But you kind of see is that, just basically random stations, they're probably pretty close to null, but you can kind of see, 3 to 4 S units of front to side. So that's actually pretty convenient for the antenna. But nonetheless, that's one more thing I need to control. So this is kind of my no knobs contesting. It's like all those amplifiers, I got knobs on them, right? And so just act like the amplifiers aren't there. I'm going to tell you more about that in a bit. So basically the whole station at this point, and I'll take you through the bits and pieces of it, is the whole station is operated from the keyboard and the radios. No knobs, no switches, no coax switches, nothing. Basically, the entire station, all the headphones selection, all the antenna selection, the filter selection, receive antenna is all done from the keyboard. In fact, it's all done from the keyboard through right log. And then you got to touch the radios, unfortunately. Although I have a rule of thumb, some people have heard me say this, if you're touching the radio, you're losing. So, and that was really the goal. So there's two computers, obviously top computer, bottom computer. They network together. They have two copies of right log. So if so right log is the program that I use. In the event that I've got like some type of problem or that somehow it gets corrupted, I've got another copy of the log. So I want to basically show you kind of the two versions of the two computers. This is what the top computer looks like. So in the upper left is the rotor control software. And the lower left is basically right log, a duplicate copy of the log. It's also good if you want to print out like rate sheets along the way. It doesn't tie up your main computer, the multiplier chart, all that other type of stuff. Lower right is DX Atlas. I'm sure we've all seen that. And the upper right is this computer does the recording as well. CQ Worldwide is pretty particular about recording if you want to compete. So you want to make sure it's working at all times. So that's basically the basically make sure that I'm getting audio to the recording device. So effectively, the way the rotor control works is there's basically 6 push buttons around each of the 4 rotators. So they're basically labeled. You can see I got one with the 10 and the 40, one with the 15 and the 20. And there's 6 presets that you can set. So if you want to go to the US, you just click on the US. You want to go to Europe, you just click on the Europe. You can basically move them all 4 of them at the same time and just moves. Now, when it gets within the location, because I found that, and sometimes you get confused, you get tired after a while, you know, you get kind of hard that the US is actually to the west and not to the east. And you kind of lose track. Is 315, is that the US? What is that? So the way it works is it'll basically display the beam heading until you get to within a certain number of degrees of where you really want to go. And then it converts from the beam heading to the actual direction. So it actually says 10 and 40 go to Europe, 15 and 20 go to Europe. Obviously, you see what it says. So it's basically relatively simple to understand. You just click. 99% of the contacts I work are going to be on one of those presets. In fact, 99% of them are on 3 presets alone, Europe, JA, and the United States. And I usually don't go south because that's what the other tri-bander is for. And so that's more or less what it is. If I actually want to go to a custom location, I move that little slider back and forth. I don't know if you go back to that. I have the program loaded. You just want to mess with it a little bit. Might not work because I can't control the other one. So if you look at this program, I mean, that's what it looks like blown up. If you click on config, there's a couple of interesting things there. Config, no, not that config, this config over here. All right. So if you config on the rotator, so you basically get to choose the name. The other thing is I always found that whenever I went there, the antennas never seem to be pointing quite in the direction that I think they should be. So you can put an offset in. Say, oh, it looks like it's off by 5 degrees. I'll offset it by 5 degrees. The other thing about the tail twisters is they have this pathology that whatever you do, don't hit the limit switch because it might not work again after that. Because the limit switches get old, they get corroded, so they basically open, and then they won't close again. So it's got its limits for a west limit and east limit. So basically, it won't let you go past the limit, past a certain limits, and then all of that is factored in when you click on the US. It factors in the offset, factors in the limits and stuff. So that's kind of how it works. You can change your presets and stuff. So that's effectively how the rotor control works. It's built on a little PC board that goes each in the controller, so the controllers still work. It's just basically a print circuit board, and that's just basically a Visual Basic application. It's probably no more than, I don't know, 150 lines of code. So this stuff isn't really that complicated, especially with something like Visual Basic, where you just basically, you know, you put the button up there, all that stuff is done graphically, you just kind of drag and drop, and then you put the program stuff behind it. So that basically rotor's solved. But in the process of doing this, the question became, okay, I made a choice of a processor, and the processor I ultimately picked is something called a pickaxe. So we've all heard of Arduinos and all sorts of stuff. So the pickaxe, what's interesting about the pickaxe is, first of all, it's cheap. It's a $10 part. And the other side of it is, it's got all of this, it's built for, the community around pickaxe is really around robotics. So it has a lot of these industrial control interfaces built into it. It's got an SPI interface, it's got an I2C interface and stuff like that. So it's actually an easy part to use. It doesn't take any hardware to program, and all the software is free. So, you know, so from my point of view, it was perfect, right? It didn't cost me anything. But anyway, so that's kind of where we started with that. You kind of see how the other stuff plays out a little bit. We can go back to the presentation. What? Yeah, I did. Those are things you can buy, like EA4TX and stuff sells those. And I'm not entirely sure I remember why I decided to build it myself. Probably because I needed 4 of them and I didn't want to pay $100 each. So I basically built them. They're pretty small. They were able to fit on the Express PCB boards, where you can get 3 boards for $50. So that's what I ultimately did.
Hey, Tom,
Yep.
if you wanted to do this with something like green herring controllers, would you use that kind of controller interface with custom software?
I bet you could, because what I did was I stayed with the tail twister protocol, as primitive as it is. It's like go to location, get location, stop. Those are like the 3 commands you've got. So I kind of stuck with that. And the reason is because if I could never get my software to work, I wanted to be able to buy software that would work. So I stuck with the traditional interface. But I eventually did some custom stuff. There's it basically detects if the brake is engaged. Because I had a situation where on the side mount, it had slipped in the mast and it was basically hitting up against the tower, and it was out there grinding away, and I couldn't hear it for at least an hour. And so now it's basically, if it goes like a minute and a half and the brake is still asserted, it'll give me an error message and basically say, hey, you might want to check something.
But you have the actual controller box levers?
Yeah, so that all still works.
Really?
Yeah.
The board inside that box?
Yeah, I did. There's a couple of tricky things. That the direction signal is a very, very noisy signal, because when you basically put the brake on, the voltage drop in the line going all the way out there goes way up. So it takes a lot of filtering, but eventually, it works. It'll smooth. You basically watch it go back and forth. So that was kind of the first one. So kind of emboldened with that, the question is, what if I went after the main controller? So remember, that was the top computer. This is what the bottom computer looks like, or this is what it used to look like. You could argue it's either more complicated now or less complicated. But once again, you got the traditional right log components. In the upper left is a watt meter. So I did my own watt meter. I remember I had 15 years to do all this stuff. So the watt meter, I wanted the ability of the watt meter to generate alarms. If I had a high SWR, I wanted to be able to basically unkey the amp. So there are a lot of watt meters that do that now, but back then there really weren't. But I also wanted more than that. I wanted to be able to have 1 watt meter transmitting, and then since it's a SO2R station, power can come back on the other watt meter, and I wanted to detect that. And if that was over a certain threshold, I wanted to let me know. Because if it was too high, I could damage my radios, I could damage all sorts of stuff. The other thing, particularly with tube amps, is when the tube amps go bad, sometimes you don't know. You're operating, you're grinding away, and you're only putting out 200 watts. So not only did you want an overpower, you also wanted an underpower indicator as well. And that's what I built into the watt meter, which ironically enough has been the hardest part of this entire project. Analog is hard, right? Digital is simple, analog is hard. Hardest part about the watt meter is actually the directionality of the sensors, the power sensors. The right is the solid state amps, I'll get to that. What I really want to focus on is this thing. It doesn't look like much, but it's the whole station. So if I blow this up, this is what this thing looks like. So what it does is, this is the interface to the station controller now, which has a computer, and I'll show, in fact, I have actually one of them here, but I'll show you a picture of it. So if I want to operate the station, the right log communicates to this box. It knows what band I'm on. It also knows that if I'm on 20, I have a choice of 3 antennas. I've got the 4-element 20, I got the Skyhawk, I got the C4E. So it knows the band, it knows what choices I have. So that grid there is the number pad on the keyboard. And so I can basically select whatever antennas I want just by using the number pad on the keyboard. And the technique of doing that is, I know there's a lot of N1MM users here. So N1MM has the ability to basically map commands to a radio to a function key. Right log has the ability to basically create 120 of those commands and map them to any key. So what I did is I basically used a whole bunch of commands that that I don't use in right log or right log doesn't use, and basically map those to a set of commands. Now the other thing that right log can do is it could send the commands to the current operating radio. It could send the commands to radio 1, radio 2. So in this case, I actually created a phony radio 3. So when I press, numpad 9, which doesn't mean anything in write log, it actually will send a command on radio 3. And then using a virtual serial port emulator to connect 2 COM ports together, that actually connects to this program. And that's how write log connects to this program, which in turn interfaces to the control box. So while that sounds complicated, it's not. It's actually darn simple. So the net effect of it is when I'm on a band, I can select any of the antennas. Yeah, Bob. I don't use the number pad. So I just use regular numbers. That actually, I can tell you a story, but I won't tell it now about how that comes into play. So basically I have all of that. On the bottom, these are my 4 directions for the receive antenna. So using the same mechanism, those are mapped to 4 other adjacent keys that are in like a little square on the keyboard. So I can basically choose any antenna I want, and I can also change the direction of the receive antennas. Those things in the middle, beverage A, beverage B, basically select whether I'm using the receive antenna or the transmit antenna on whatever band I'm on. And then PTT has to do with headphone switching. So basically all of that. And then the other stuff, like all the filters, selection, all that stuff, that's all done automatically as well. Likewise, the headphone switching. So it's all done from this box. It's all displayed here. So there's no clicking on this box. There's no moving the mouse. It's all done from the keyboard and write log. That make sense? Okay. So anybody who ever sits down in front of this radio always wants to click on these things, including me. I make that same mistake. So the other thing about the directions, yep. What? Yeah, but you never want to touch those. So the question is, how do I get the commands out of write log into this program? Right. So what I do is I say numpad 9, and I basically, when that gets typed into write log, it basically will generate. There's a set of 128 match codes I can use. I'm up to 100, so I'm getting close. And it'll basically take that macro and send it to K3. It's not sending it to the radio. It's sending it to this software program. It just wants to look like a radio. But what's nice is it doesn't send the command. You can set it this way. You've got a whole bunch of choices. It doesn't send the command to the radio. You can do that. That is an option. But you can send it to a specific radio. In this case, it's radio 3, which of course I don't have. And I basically connect that to this program. Yeah, right. It just talks to it on a COM port. And then I use a virtual serial port, basically pairs that. So this guy thinks there's a COM port that's sending him commands, and the other guy thinks he's talking to a COM port. And in fact, they're just talking to each other. Easy stuff. And that software, the VSPE stuff, is pretty cheap.
If you wanted to use the mouse, you could just have these radio buttons.
Yeah, but I don't want to touch the mouse. I want to take my hands off the keyboard.
I know you don't.
In fact, it's even annoying enough to actually move over to the number pad. So in the related to that thought, so I have this thing. Remember, this is on the lower computer, and I got the rotor control on the upper computer. So what I found myself is, yeah, it's nice to pick the antennas, but every once in a while, I'm transmitting on the wrong antenna. I'm trying to run Europe, and I'm beaming to the US. So it'd be really nice to know is what direction, not only can I select these antennas, what direction are they pointing? So they're on 2 different, even though they're on 2 different programs, the same virtual serial port will actually let you talk over the Ethernet, one COM port over Ethernet to another COM port. So it looks like they're on the same computer, and they're not. So the rotor controller actually talks to this program as well, and actually will display the beam headings alongside the radios. So I can see, I can select the radios, and I can also see where they're pointing. So there's a couple of other wrinkles in this. If you hit config, so this is basically solving old problems. Anybody ever use Dunestar bandpass filters? They fail, right? 10-meter section fails, 15-meter section fails, so they fail. So a couple times I had them fail. So I actually have in that config, you can basically go by band, left radio, right radio, and you can basically bypass a failed filter section. Otherwise, you got to pull the cable out, in which case you don't have any filters. So you can bypass. So Is it the greatest feature in the world? No, but it comes in handy. The other one is I've gone to solid state amps and homebrew, and we could do a whole topic on that too if you wanted to. One of the biggest issues that I had, in fact, by far the biggest issue I had was the filters. And I had a lot of filter failures. So basically you could have the 20-meter filter fail and you can't use the solid state amp anymore. So what I did is I have the tube amp alongside of it. So if I lose the 20-meter filter, I can actually select which amp I use by band. So if I use one filter section, I could use the solid state amp on all the other bands. And I can use the tube amp on the one band that fails, and I still got automatic band switching. Now, if two of them fail, then it becomes more of a problem. So what this basically does is basically say, I've got two amplifiers on either side, like a primary and a backup, and basically says by band on each side which of the two amplifiers to use. So that's something else that's built in the config. Thing is, once you've automated this, there's no limit to what you can do. And I think that's the real message on this stuff, is if everything is hardwired, you actually don't want to make station improvements because it's too hard to keep the rest of the station up to date. But the problem with this is once you automate it, it's like, you know, every day you wake up in the morning, you got some new idea.
So is the things like the switching you were just talking about done with relays?
Yeah, yeah.
Because we noticed in our station, relays seem to be as problematic as anything else.
I don't know if I'd go that far. There's a thing at the end. I kind of have a bunch of opinions on that topic about relays. I've actually come a long way on that topic. But one thing I should add is that, remember that 8x2 box so I've replaced that. And the reason, and even after I used it for 15 years, and the reason why I replaced it, I started to get this symptom of what for lack of a better term, called the half harmonic. That is, if I was on 28.4, I would get massive interference on 14.2. And bypassing that box made it go away. So either it's the connectors got old and corroded. You know, remember I had the limestone dissolve in the back off this box. But so either the connectors got corroded. Kind of one of my pet theories is it could have been the diodes across the relays, or it could have just been RF going back into the control lines and getting re-radiated somehow. So I never got an adequate explanation. But replacing that box made it go away. Now, I'll talk a little bit about interstation interference because that's by far and away the most difficult problem and the most confounding. And filtering never solves anything, rule of thumb. So anyway, this is what the control box looks like. The brains is right here. This is the processor. It's kind of on the motherboard. This has been many ECOs over time. Inside the box is actually two W5XD memory keyers. So it's set up for multi-op as well. So you can actually do two multi-ops. So the W5XD memory keyers are now obsolete. So I've been trying to move away. Many years ago, for whatever reason, I actually designed that the WinKeyers would work in here as well. So I actually have the WinKeyer chips in there. So I can actually run with WinKeyer or W5XD multi-keyer. That's kind of on the motherboard. This is the processor here. It's 28 pins. But here's the brains. Well, I shouldn't say the brains, but the important thing. And that is, how do you get all this information in and out of the processor? And what those chips are is what's known as I/O port expanders. So they basically communicate with the CPU over a three-wire bus. And then each one of them, the surface mount ones have got 16 ports and the other one's got 8 ports. So between these 8 parts, I can actually input or output 96 signals. And that's how the whole station is monitored. So the whole station comes into that core. So you can imagine what the wiring looks like. But anyway, so it all comes into that core, plus there's some pins on the processor itself. So it's really, really easy. I can get a ton of I/O. In fact, I'm thinking about another generation of this box. It's long overdue. But 96 didn't prove to be enough. So I'm actually like making trade-offs of what I need and what I don't need anymore. But so ultimately, I want to go to like 128 at least. It doesn't have to be a relay, but a lot of them are relays. That's what all this other stuff is relays. I had a problem with relays. You know, if you short the cable, you can fuse the contacts on the relay. So some of them are transistor driven. So that's why there's been a lot of evolution of this. I wouldn't consider this a finished product, but it's kind of a bunch of lessons learned. But the net of it is, a lot of them are driving relays. You figure there's 10 antennas times 2, that's 20. You got the 6 bits for the bandpass filters times 2, that's 12 more. So you can see how you can get up to 96 relatively quickly. You got all the band information coming in. But anyway, I got one of these if you want to look at it. But that's kind of, the whole station is controlled out of that box. That program, that little picture of a program, basically interfaces to this box with a serial port.
How much concern about single point of failure?
I got 2 of them. That's why I have one here. Yeah, I've had this box fail once. And it was CQ Worldwide 2 years ago, and it failed in the first 5 minutes. And maintaining 48 hours of motivation, you're competing against N6MJ, so it took like an hour and a half between this. I had a power failure. It was like everything went wrong, but it's like, okay, you lose like the first hour and a half, and you're 500 Qs behind. So that's a problem. But so I do have 2 of those for exactly that reason.
So when it fails, what's your first inclination? Try to fix it or swap it out immediately?
That's a really good question. So the first thing is, like, what the hell is wrong? Like, you're trying to figure out. And the fact that I've never had one of these fail before, that wasn't the first thing I went to. And there's a lot of cables on the back. So unfortunately, I've learned how to do that. Is you put one on top of the other and you move one cable at a time. But that doesn't get done in no time. So the other thing that I kind of stumbled upon in this process, has anybody ever used a program called AutoHotkey? So it's the syntax is excruciating. The functionality is the coolest program I've ever seen. So what WriteLog can do is it can map any function to a keystroke, but it can't map multiple functions to a keystroke. So AutoHotkey can do that. So like if I want to go into, there's a keystroke that puts it into dual CQ mode. So what it does now is it basically will swap the headphones. It'll actually change the messages in WriteLog, because I dynamically change the voice messages when I'm in dual CQ mode, like during a contact. It checks to see whether there's any competition for the antennas. It's like a whole 20-line program before I actually go into dual CQ mode. So that's part of it. The other thing is it comes with a program that allows you to go into other programs and set and read the fields in the programs. So I had been hounding Wayne for 15 years. Wayne is W5XT, the WriteLog guy, for a unique +1 capability. So I eventually wrote my own. So it basically took, as I typed in the keys into here, it basically read those using AutoHotkey, put it up into there. That says 7050. That's not a valid call sign, obviously. And then basically use that. So basically, I shamed him into it. He's implemented it now himself. But the ability to get information from one program into another and set the information is really, really cool. Like for instance, I wanted to know when I'm doing dual CQ and I type back, you need to get the microphone back if you make an error. So whenever I type something that looks like I'm making a correction, like a backspace or something like that, it basically stops the dual CQing, so I have the microphone back. So now if I want to restart, the question is I need to know which radio I'm on. So I can basically read this field and say, what's the color of the background? And I can figure out which radio was the one I was using. So there's like all sorts of really, really cool stuff in there. The other thing that it does, which is basically where most of the pain has come from, is there's a lot of programs here. They all have like fields that need to be entered. They all need to be configured. Even WriteLog doesn't come right out of the box. There's stuff, every time you load the program, you got to like connect the networking and all that type of stuff. So it can do that. It can basically launch all the programs, pull up all the menus, enter all the data that you want to put in the menus, close all the menus, and kick it all off. So what I could do with the operating, particularly if something goes wrong, like you like panicked, oh my God, what am I going to do? So you start AutoHotkey, you type one key, a minute later, all the software is up and configured and ready to work, guys. So you never forget anything. You never forget to turn networking on. You never forget to turn recording on. You never forget any of that stuff. And all that's done with AutoHotkey. The syntax is ruthless. If it isn't perfect, it doesn't work and it doesn't tell you. All you know is it doesn't do what you want. That's kind of, but it's really, really, really powerful stuff. It's one of the coolest things I've ever come across. It's free. But the ability to basically transfer data between programs by basically scraping the fields, entering stuff, it's really, really neat. So the reason why I told you to ignore those 2 amps in the middle is because, as I said before, those amps are actually the backups. But if I need the backup, then I need to reach the knobs. So yeah, there are knobs, but I'm not using them. At least I hope not to use them. So the solid state amps are on the outside. There's one here, one here. They look curiously like ALS 1300s. It turns out I bought an ALS 1300. Solid state amp was a 10-year odyssey of failure for me. And I eventually broke down and bought an ALS 1300. And the 2 times it worked, it was awesome. The 7 times it didn't work, it was not nearly as awesome. So I basically redesigned the entire thing, but I kept the mechanicals because that's a hard thing for me. And then once I got one of them working, the great thing about MFJ is they'll sell you anything. Any part on the parts list can be bought individually. So I basically bought the mechanicals for the other one because I already knew how the parts fit it. And I had already like made the brackets and stuff and the print circuit boards and stuff. So basically the 2 solid state amps are here and here. And I got these guys as backups. And so basically the solid state amps are gone. No, I'm supposed to say that the tube amps are gone. I've not made a contact with the tube amps in probably 2.5 years. Power supplies are in the back. I have a brief picture in the back. That's kind of embarrassing, but I'll point that out.
How much power on the
Well, it's kind of a long story. I run it at 1,000 watts by agreement with the agreement with Barbados. So we kind of, that's a long, ugly story. Is I get there and they say, you get the license. License says you're only good for like 250 watts. They said, oh, don't worry, we've got special dispensation for contests. So it's like, well, that's not really good. So I went to the ministry and basically negotiated to get something in writing allowing me authorization for 1,000 watts, and that's what I did. How much could they do? If I had enough power supply, they're using the BLF 188 XR, so they could probably do 2,000 watts easily if I had the power supply. So this is NAQP 2018. What you notice is that this guy's here, if I don't remember from the previous slide, but that's where the rotor boxes were. So in my desire to get crap off the desks, since I don't have to touch the rotor boxes, what if I could just get rid of them? So basically the rotor boxes are in that closet now. And they communicate to the top computer. I found this thing, Get Console. It's basically a USB to Wi-Fi adapter. And that's how it talks to the main computer. So I basically have no cables to the computer anymore. Basically the Gizmo, the serial to USB 4-port adapter gets connected to the back end of this dongle, and the dongle just sits on top of them, and it talks to the top computer. So I got all the control cables, all the rotor cables, all the connectors, all that crap out of the back of the station.
You're using a wireless USB connection between the rotator and the computer?
It's more like a wireless serial connector. Because the serial port's out of the back of the rotor control box. It goes through the Gizmo to a USB, and then there's this device. It's a USB to Wi-Fi. And then the Wi-Fi on the other end. And it worked perfectly right out of the box using the virtual serial port software that I had bought off the shelf without any modification. That was remarkable. So that's what January looked like. So it's basically getting simpler and simpler and simpler from an operating perspective. One thing you can't see is kind of up where it says NAQP 2018 is where all the coax cables come in. So there's a bundle of 10 coax cables plus some spares, plus the 4 rotor cables all coming in, and the power to the room all coming in a bundle. This is my wife's idea. KO1JJR is my wife. So all these cables come in, and when I was in the back room, they were all like piled up on the floor. In fact, I've never had a station that didn't have a pile of cables on the floor. Except now, so what I didn't want to do is have to do what I did before, and that was crawl on the floor underneath the cable, underneath the radios with like the dead bugs and all that other type of stuff under there to connect it. So now they come in through the top of the closet, and then there's a curtain rod or a closet rod, and basically all the cables spooled up on the closet rod. So all the stubs, all that type of stuff is all up on the closet rod. And then this is the box that replaced my 8x2 box. That's an Antenna Genius. Turns out it's a little bit too smart for its own good. And these things actually, K9YC might be proud. So the C4 doesn't have a good pattern on 15 meters. So on the ends of the band, the SWR is really awful. So what I did is basically it's 2 sets of boxes. It knows what frequency I'm on, and basically it switches in stubs as I tune across the band. So I basically get a flat SWR across the whole band. It's not beautiful, but that's my south antenna. So I just want something that I can go to. Now this, unfortunately, first of all, I put the rotor boxes in there, but the other part of it is this doesn't look like this anymore. And my project for last year is I wanted to be able to beam in 2 directions at once. And from Barbados, Europe and US is almost exactly 90 degrees from each other. So one is off the null of the other. So I wanted to be able to beam in 2 directions. So my brainstorm is I was going to build a box that was going to pass through A, pass through B. Actually, would have a pass-through and a unit, and I was going to basically plunk it down right here on the output of these boxes, and I could select more than one antenna. Actually, 2 is the only other option I had. I could select 2 antennas, and I can either bypass the unit or basically pass through the unit. So as brilliant as that was, it had 2 flaws. First of all, the antenna genius won't let you attach 2 antennas to the same port. Not sure why. It took them a year to fix that problem. But they did. And the other side of it, proved to be more complicated than it let on. So eventually, I solved all that problem, and I've got the ability to beam on multiple directions on all the bands. But the problem is when you're doing dual CQ, since I needed a tri-bander on both bands, so I basically went to a triplexer. So now I got a triplexer in the closet next to it. So it's this beautiful by my standards picture of a closet is actually a lot more complicated now. There's actually 5 more boxes there plus the high-power triplexer in the closet next to it. The problem with the stack matches were I wanted to be able to control them from my station controller that I already had. And the other side of it was those were 3-port devices. They effectively were the same thing. They basically just show up 1, 2, or 3 ports together and run them through either 2-to-1 unit or not, or 2-to-1 unit or not. So I just felt like I could do that myself in a lot smaller package. Jim?
Yeah, just a comment. I did bench measurements on that particular 8x2 switch. It is spectacularly good at RF.
Yes. Yes, it's like 80-something dB.
Oh, no. Better than 100.
Better than 100.
From anything that's the 8x2.
Yeah.
Yeah. 6x2 was in the 75 to 80.
Mm-hmm. So, I've been pleased with it. I didn't like the idea of all that intelligence in a place where there was all that RF. So the first version of it, I basically took the board out. I don't need his intelligence. I already got my station controller. I don't need him trying to outsmart me. So I took the control. I took the genius part out. It just became antenna. And so the big issue with this box was the insertion loss was awful. Not the insertion loss. The return loss was awful. And I sent a note to Ranko and I said, I can't believe you shipped this box. It's got through SWR of like 1.6 to 1 on 10 meters. So I saw him at Dayton, and he said, Tom, I got your note. I did your measurements. I want to let you know we're going to make this right. I'm going to send you a new version of the box. So a new version of the box comes in, and basically this printed circuit board that I took out is actually connected to the relay board, so now I can't remove it. But he fixed the problem, and he actually did it in a very, very clever way. He basically cut the strip line in half and basically created 2 like smaller units, 2 4x2 switches. It's actually quite clever what he did. It wasn't as trivial as that. He just put some caps and coils and figured something out. So I give him credit for that, and he fixed the problem that I could actually connect 2 antennas to the same port. But anyway, that was kind of her. Kind of a little tedious to roll them all up, but that actually was $1 million idea. Yep. Yeah, it was. It varied by port, and 1.6 was as good as it got. Yeah. In fact, Bob, if you remember, I had you come up with your microham box just to make sure that my measurements were okay. Yeah, the microham box was like 1.05. Yep.
When did you experience that issue with Ranko's box? I got several.
I want to say it was. He's got like a version 1 and a version 2. The version 2 has got like a daisy chain connector where you can daisy chain these boxes together. Yeah. So if you have that one, then he's probably fixed it. If you have one without that, he probably hasn't. Now it's actually good, although and that's only 10. This you supposedly could do 6 meters too. So I wasn't interested in that, but I'm sure it didn't get any better. the thing of it is, you got to pick the right ports. Not every port, you really got to pick the port by frequency. There's no doubt about that. Okay, so the price of automation is basically the back of the is the back of all these wires, right? So this is supposedly wireless. So if everything's going to be connected, so the controller box is here. In fact, the wire density is so bad you can't quite get it. But a couple of things about that: having a shelf on the back of the bench. There's actually 2 shelves. You can't see it. There's one underneath. That's a big win. It gets the stuff off the desk and off the floor. The other thing I really wanted to do is I wanted to get all the cables off the floor so I can basically, sweep the various refuse that builds up while I'm not there. No. Basically the business failed and they let me move back into the house. But they had gutted the house, so now it's not livable anymore. So there's no kitchen, there's none of that stuff. So we actually have an apartment that we stay at. So this room, kind of looks pretty cool, but the whole rest of the house is basically just storage. There's nothing else in that building. So, the electricity comes in over there, it comes in across the floor, across all the cabinets. One thing is that all the outlets are basically mounted on the back of the desk. So the outlets are pretty convenient. This thing here, these are my rotor cables. They're separate from the other cables. So when I move the rotor cables, I move those too. So I don't have that on the floor anymore. So I'm kind of a purist. So basically nothing behind. Being able to get behind the tables is really, really important. You don't have to hang upside down and try and put the cables in and out. And so this is, really, really been convenient for me.
NCCC laughing at your. So you have more spaghetti than that.
Yeah, but remember, this is single op. So that.
You mentioned the power coming in. Do you have power?
I do now. So, I like I said, there's nothing about the station that doesn't have a story. So I stayed away from generators for a long time. I don't know anything about motors. I don't want to store gasoline. And my fear was if I got a gas-powered generator, the day comes when I want to use it, it isn't going to work and I'm not going to know how to fix it. So eventually I went the propane route. So I've actually got a wired-in system. It's propane-based. They could not understand why I did not want to have a propane tank on site. I wanted to basically run, a decent-sized generator off of the tanks that you can get at the gas station. What?
5-gallon tanks?
No, they're like 20-pound tanks, 20-pound tanks. Yeah. So I'll tell you why I did that. Is I can get them whenever I want to get them. I don't live there all the time. I can't get deliveries of gas, right? So I basically just connect up the tanks. I got 2 of them in parallel. I got a whole bunch of them. Because, I'm not there. I'm not trying to survive a hurricane. I'm trying to survive a 2-hour power fail. So related to that, since the whole station is automated, the last thing I want to do is have a power fail, even if it's only for 30 seconds. That forces me to reboot all these computers and get everything all configured up. So I basically I've gone to Nook computers, which conveniently mount on the back of the monitors. And so they will run at 12 volts, so at 13 volts. So I basically have the 12 volts through a battery. And so basically it will stay up long enough for the generator to turn on automatically without having to reboot any of the computers. So the good news is I've never had to use it yet. So, but whenever I throw the big switch, it seems to work. 7.5. Yeah.
How long will it run on a tank?
A really long time.
Just one tank?
Yeah, probably 6 or 8 hours. Remember, I've only got this and air conditioning. Right? There's nothing else in the room. There's nothing else in this whole building.
Island power stable?
What?
Island power stable?
It's become less so. There's been more outages as time has gone on. For anybody who's a real power expert, actually have a pretty serious power problem at this location. It seems to me I've got a relatively high neutral to ground voltage, and a ton of and 3 amps will flow through my ground line from the service entrance to the ground rod. So, and they keep sending people that come out, and they say, "Oh, that can't be," but it is, and they say, "Oh, you're right," but not much of a solution so far. On the other hand, resolving RF problems, they're 100 times, well, everybody's 100 times better than PGE, but what I'll say is they'll actually respond. You talk to somebody and they'll come out and there'll be a million apologies and they'll go work on an RF problem, like if you got stuff. So they've fixed a few of them for me over the years. So the other thing that is kind of cool is WriteLog is basically integrated with some of these SDR dongles. So that's what this thing is up here. So for, oh, where'd it go? It's a $25 SDR dongle. $25. Okay. So basically, you connect this to the IF, and basically, WriteLog will do a spectrum display for you. So how does it compare to? It'll do a waterfall, and it'll do the spectrum display. So you got the P3s. So what the WriteLog will do is for $25 each, you basically display the waterfall on top of the band map, get all the call signs in it, and then you can click on the band map and actually QSY the radio. $25. So as a piece of lab equipment, is it as good as the P3? No. For the purposes of contesting, is it better than the P3? Yeah, at 1/40th the price. So it's also kind of cool. You go along the bands, you just kind of click, bing, 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 and you just kind of keep working, guys. It's works pretty well. Okay, so just kind of some tips. I kind of put this in the category of paranoia. Some of this is folklore. Some of this people won't agree with, but kind of from my point of view is maximize common components. First of all, it's fewer things that you have to learn how work, right? If you have a tail twister, if I hit the limit switch, how can I still move the tail twister, right? There's all those little things of how do you work around, and you don't want to learn that for 4 rotors. Plus, if anything goes wrong, it's nice to have common components. So I went through 6 rotators in the first 18 months, and I haven't lost one since. You eventually learn what works and what doesn't work. And so I've got 4 rotators and 2 spares down there. Label all the cables. You saw what that looks like. Don't label them with flags, like little things that stick off on the side of the cable, because inevitably you're going to have to pull a cable through a bundle, and you don't want to have a flag sticking out. All documentation in one place. So all my documentation is all digital. I don't want to know about manuals. It's all in Dropbox. So I can be at the top of the tower and take out my phone and say, okay, what does the pin out of this thing look like? So all documentation in one place. This is paranoia, no custom cables. No custom cables. Everything wants to use standard cables. One of the reasons is I have a custom cable, I rearrange the shack, the cable's too short, now what? The worst thing you can have, the worst thing in the world you can have is a non-standard custom looking cable. In other words, like a DB9 that isn't straight through. So I made that mistake. So no custom cables. I'd rather have adapters and standard cables than basically make custom cables. And basically you trip over one, rat chews through, whatever happens, you don't want to be without a cable. So basically, whatever they are, big believer in that. Another level of paranoia, no painted project boxes. As you can well imagine, you couldn't quite see it there, but there's a lot of project boxes. So the problem with painted project boxes is, not to go too crazy on the pin 1 problem, but there's countless times where things that I thought were connected to ground weren't. And basically, every time you want to connect to the box, you have to scrape the paint off. And then if they become a little bit loose, so basically no painted project boxes ever again. So everything that I do is in basically die-cast aluminum boxes. This one, connectors matter more than coax. Obviously, it's within bounds. But I've had more connector-related issues than I've had coax-related issues. And I was not a believer in the best possible coax connectors you can buy, but I am now. And the number of interstation interference problems that were resolved by either tightening a connector or whatever, I'm sold. I'm completely sold. To the point where on some of my equipment, but not all of it, I've actually replaced the SO239s as well with Amphenol, because not everybody uses those. And the last one, can't have too many caps. Every static interconnecting signal that goes between these boxes for control has got a bypass cap on it. Whether it's the print RF in, RF out, it's just like one of those things. It's really easy to do. And there's effectively no RF interaction with any of the digital signals in the entire station. So there's no like LEDs that light when you transmit or any of that type of stuff. Analog is another story. Most of the interconnect problems, I should say almost all the interconnect problems have always been related to either recording audio or microphone audio. And, does it work? Well, so that's my office at home. So I'm guessing is that this is probably the winningest single lap contest station in the world. So something about all this stuff seems to work. So sorry about that. So this is, I stole this from Dayton. 2BSIQ is CT1BOH is a long fancy name for dual CQing and interleaving QSOs. So there's a couple of things about that matter. One of them is if you're going to do this, you got to get serious about interstation interference. When you're SO2R and as you kind of come across a bad spot, you can just basically stop transmitting until you can hear. You can't do that because you're receiving all the time. You're transmitting all the time, you're receiving all the time. So you got to eliminate interstation interference. This is the hardest, most difficult, most confounding issue that I have. And never does filtering solve a problem. It's always some form of intermod, either a bad connection, some interaction with something. And I've gotten through a lot of stuff, but filtering doesn't solve these problems. But interstation interference is the most confounding. On phone, I'm in pretty good shape. I can go the whole contest and never hear the other radio. CW is a little bit harder. Think about receive antennas. If you're going to basically be constantly receiving, you need to be switching your receive antennas at the same time. If you're on 80 and 160 and you're dual CQing, you need to be changing direction. You don't want to be constantly changing every time it switches to change your receive antennas. 3 radios, particularly now when the sunspots are down, you have to figure out whether 10 meters is open or not. So how does that fit into this whole equation? And for me, the entire station is set up for SO2R. So there's 2 feed lines coming to the station itself after all that switching. I'm eventually thinking of going to 3 or 4. That's what the next generation box will be about. So this is a paranoia thing. I hate switching high power signals based on TR external to the boxes. So I don't like to have something outside that I'm transmitting that I'm switching based on PTT. That's basically potentially hot switching the RF. It can be done. There's no doubt that with good engineering, you can solve this problem. That's all well and good until something breaks and you substitute another piece of equipment. So I really don't like doing this. In fact, there's probably outside of the radios and the amplifiers themselves, there's no TR switching. There's nothing that changes between transmit and receive external to the actual radio and the amps.
What are you talking about external what switch?
So, like say for instance, you were, for a while I was basically switching in the receive antennas because the TS-850 did not have a way to easily do receive antennas. So I was basically transmitting, basically RF sensing, and then basically TR switching to switch the receive antenna in on receive and then go back to the transmit antenna. But I'll give you one just to generate a little bit of controversy. These SO2R amplifiers. The amount of switching that happens every time you switch from the A radio to the B radio is staggering. It's staggering. You just listen to it. And in fact, on the Renko box, they did a demo where it was basically took like several seconds to switch, like from CQ to CQ, from radio to radio. I'm guessing that's to let the relay settle. That is way too long. Yeah, the first demo. I'm not quite sure if that's that way now. Yeah. Yeah. So that's not doing TR switching, but it's basically, I don't want any race conditions. If I got I have a radio and an amp and a radio and an amp, then I'm transmitting on one, I'm transmitting on the other. I'm not switching between them when I'm changing A and B. I'm not switching anything from TR. It's just, the more you tempt fate with these race conditions, the more they're going to hurt you, particularly when you start substituting equipment. I'm not saying it's a difficult problem to solve. It's just a hard problem to solve with all the variance of the equipment that you may have and the things you may substitute in the heat of battle. Headphone automation. So the first time I did the 2 radio stuff, I had one radio in one ear, one radio in the other ear the whole weekend. And I dreaded that and I feared it for a long time. It's not as hard as it sounds, but it's tiring. And there's no doubt that when you get to the end, it's really slowed down. So you can't automate headphone switching with 2 radio with dual CQ because the overlap between the QSOs is going to be non-zero. So you got to hear what's going on. So basically the way that what I've implemented was, if one radio is transmitting, then I don't need to listen to it. So when one radio is transmitting, both headphones are on the other radio. But when neither radio is transmitting, then they're split. You have to be able to listen when neither one is transmitting. Otherwise, you're going to keep missing cycles. Guys are going to call and you're going to keep missing them. And the other one is know what's happening. Is now if you're switching your headphones based on the radios, it becomes more of a video game than actually operating. So you're like typing along, and WriteLog is really, really, really good. For anybody, I mean, I don't want to do much of a WriteLog commercial, but WriteLog in the contest simulator simulates this thing really, really well, and you got to get a sense of the automation. When things are going well, you just keep typing. You don't have to change radios, you don't have to do anything. But you lose sight of which radios like you're working guys on. And you get like 5 contacts down the log, and it's like, oh, ZB2X called me, I should have moved him to another band. And you kind of lose sight of that type of stuff. And the other thing is when stuff breaks down, now they're in one in each year, and you can't remember which one is which. And it's really bad in the WPX, where you could basically have 2 contacts breaking down, asking for repeats of serial numbers on 2 different bands. And so what WriteLog does not have, and I have no better way of implementing it, is some way of visualizing what the heck is going on. I think better use of color codes and that type of stuff. It's just kind of understanding what's happening. And then these are just some references for things that I mentioned in case you wanted to follow up on any of them. And then that's it. So.
I want to emphasize the point that you made about bypassing control.
Mm-hmm.
One of the serious errors of the YCC box, for example, is that they have no concept of shielding.
Mm-hmm.
So if they have a paint issue, they have the connectors insulated from what chassis there is, and wires come through this box, unbypassed. So anytime a wire bypasses or goes through a shielding enclosure, it ain't shielded no more. Because the wire is bringing noise, crash, whatever in. So I just want to emphasize that. It's absolutely critical.
Yeah, and if you basically ground the shield at the entry point, assuming you have a non-painted box, and then basically bypass the 2 actual signals, it may be overkill, but it's never hurt me.
Yeah. There's a common problem with the Astron power wire.
Yes.
Where the green wire comes into the box, it goes to the leg of the terminal strip, which is insulated from the chassis by paint.
Yep.
And then a B minus comes to the same terminal strip, which is also insulated by paint, and now you've got an RFI problem.
So I basically ground off the paint of my Astron power supplies. Exactly that reason.
You were going to say something about relays, and I'm wondering, do you have open frame relays, sealed relays, vacuum relays? What make those decisions?
The solid state amps, because there's a TR switching component, I've gone to vacuum relays on the output and read relays on the low power input. So they're all sub 5 milliseconds for sure. For the other amplifier box, since they're not switching in real time, I just basically have open frame relays, and those have been pretty good. So I was very worried about open frame relays and would they radiate, whatever. And in the end of the day, there isn't that much of that. For all the relays in the station, I'm frankly I'm more concerned about the interconnect than I am about the relays themselves.
The open frame relays, they corrode salt in the air, humidity, things like that.
I think that's what happened with that 15-year-old box. I mean, I have no technical understanding of how there could be such a thing as a half harmonic, but it was real. So I got to believe that's got to be some nonlinearity. Other paranoia is like whenever I've got a relay with a diode across it, I basically put capacitors all across all my relays, capacitors across all my LEDs in all the boxes. Just it's like once you learn a lesson, you learn it forever.
What made the biggest difference in carrying your station?
I'd say good connectors was probably the biggest thing, and the isolation of that antenna genius is quite good. And I think the quality of the connectors and the quality of the relays, although the relays in there are pretty small, I think all of that helped. But I've got a serious problem now that my next trip down there I really want to work on. Of 20 into 10. And it originally it looked like a triplexer issue, but it basically happens with all the antennas, and it all depends on which antenna I'm pointing at and stuff like that. So it's going to be one of these. The good news is there's not much in the house that I don't control. So I'm going to start with basically running the 2 radios off the car battery and then directly connecting the antennas to it. And if I still have a problem, well, I'll deal with that. But if I don't have a problem, then I can basically start to rebuild the station until I figure out where the problem ultimately is. But interstation interference is almost always intermod. It's always a bad connection or overload of something. And
How much is it leakage through the cabins? For example, you put a dummy load on the radio, it's still very
no, they'll go away. That's why I think it's the radios. Like I can put a dummy load at the antenna on the tower and everything's great. And then I transmit it to the antenna and it's bad. So I got to believe that that radiated signal is getting into something.
Do you have a good way of eliminating the possibility of re-radiation by something in the vicinity? We have all these metal roofs.
As do I. In fact, they just replaced it. So, you know, the diode caused by the gutter downspouts and stuff like that. I don't know. I mean, it's just, you just kind of keep searching these things out. And the problem is there's no systematic way of doing it. If it was like stuff coming from my power supplies, I could see that on the spectrum analyzer and I could do a bunch of stuff, but stuff that happens on transmit is really, really, really hard to find.
Use an RFI box hunting techniques or something.
The problem is the towers are all within like a 100-foot triangle. So it's kind of hard to get out of the near field. The VA6AM high power triplexer. First of all, there's a piece of equipment that measures like minus 104 dB isolation to the limits of my VNA. Basically, I've never seen anything quite like it. Yes.
W3LPL has talked a lot about passive IM. I think that's what you were hearing in W7RN when I came over. And one of the many places he talks about that happening is in switch mode power supplies that are around, and also the bond or the lack of a bond between, the lack of a bond around the rotor. So in other words, the junction with the rotor between the boom and the mast.
Yes, that's exactly right. And that's actually one of the things I want to look at is the other thing is that guy on the side mount, it didn't dawn on me until now, is that the whole antenna is isolated from the tower because the side mount is using those phenolic blocks with the bolts through them simply because they fit nicely around the legs of the tower, not because I wanted to insulate it. So that entire antenna, that Skyhawk, the only connection to ground is actually the rotor cable and the coax. But that's 200 feet away. Okay, so sorry I ran over. Hopefully that was interesting. And,
thank you very much, Tom. You've given me a lot of things to consider and look at, so I really appreciate that. With that, thanks everybody for coming. We will see you a month from today, somewhere in San Jose for the next meeting.